this topic is basically just a recap of IGCSE or GCSE probabilities, though there are a few new things which we're going to look at the end of the video. Let's do a quick recap first. So when you're representing multiple events, such as tossing a coin 2 times, okay, so one event would be tossing it once, multiple events is 2 or more. So we know that when we toss a coin, there's 2 possible outcomes, heads or tails. So if we're throwing it twice, we can make a graph representing the 2 scenarios, okay? So first, you can get heads and heads continuously. So throw it once, it's heads, throw it another time, it's heads again. You can do heads and tails. You can do tails and heads, and tails and tails, depends on the order. Okay, so we can have a graph like this that represents it, and we're just going to draw lines that go across the points. So you might be asked to represent the different scenarios using a graph like this. And then there's the famous tree diagrams. So for coin 1, we can get either heads or tails. For coin 2, we can get tails or heads again, followed by the first one. And this means that our possible outcomes are heads and tails, heads and heads, tails and tails, or tails and then heads. As you can see here, the chance of landing blue is going to be 3 out of 4. But what if you spun this wheel 3 times? What's the chance of it landing blue twice out of these 3 times? How do we figure that out? So firstly, if we use a tree diagram, we'll see that the first outcome can be either white or blue, okay? Then for the second spin, again, it can be followed by white or blue, third spin again. So what are the outcomes? Okay, we first draw this, and this helps us figure out the outcomes. This is what matters. So you can get white 3 times, you can get white 2 times, and then blue. There's WBW. Okay, so how many of these outcomes involve 2 blues? Well, these ones. When you spin 3 times, there's 3 occasions in which there are 2 blues, and this means that it's 3 out of 8 because there's 8 outcomes. Another example, what if you were to toss a coin and also throw a die at the same time? What are the possible outcomes? Well, you can see that you can get a number out of 6, and you can either get heads or tails, and this can be represented in this graph. So what is the chance of landing a head? 6 out of 12, as you can see here. What is the chance of landing a tail and rolling a 5? Well, it's going to be right here. Tail, 5. It's 1 out of 12. And lastly, what is the chance of landing a tail or, not and, rolling a 5? Well, these are the chances. Landing a tail can be any of these, and rolling a 5 can only be these two. Well, they go all together, and so it's 7 out of 12. These tables, in my opinion, are the easiest probability questions you can ever get. So, what's the chance of wearing yellow and having blue eyes? Well, wearing yellow is right here, and having blue eyes is right here. So, having both involves 10 occasions out of the total, which is 62. Easy. What is the chance of not wearing yellow? Well, it's going to be 22 out of 62 because it's anything that isn't in this column. It has to be in this column, and the total for that is 22. Moving on to Venn diagrams. Well, for this question, always have in mind the total. So in this case, it's going to be 42 if we add up all these numbers. Have that in mind. So what is the chance that the person plays rugby only? Okay, well, that's going to be 9 out of 42. Rugby only. This is rugby and other sports, so rugby only is going to be 9. Simple. what's the chance that they play football and basketball? Well, that's going to be anything here. Okay, so 5 and 2, that's 7 out of the total 42. What is the chance that they do not play either football or rugby? Well, that's going to be anything that's basketball only or that involves none of these sports, and that's 17 out of 42. Moving on to the new stuff, so addition law. This states that for combined events, or events that can happen at the same time, such as the sports played, you can play both football and rugby at the same time, right? So this is a combined event. This would be the formula to figure out union. Okay, so A union B equals the values in A only plus the values in B only minus the intersection between them. Now, there's cases where there's no intersection because, well, the intersection equals 0 because these events are called mutually exclusive events. They're events that cannot happen at the same time. For example, test results, okay? You can't have an A or an 80% and a 60% at the same time. That's not possible, okay? They're mutually exclusive. And the formula for these would be that the union equals the values in A plus the values in B. That would be it. More formulas. So, what does this mean? What does this symbol mean? The probability of A given B has occurred, or uh, the probability of A happening after B has happened, okay? And this equals the intersection of A and B divided by B. This could be the other way around. It could be if the B was here and the A was here, it would be the probability of B given A has occurred, okay? Now, this, as I said, is A intersection B, total number of values in B, and this is going to link a lot of times in questions with this formula that we've seen before. An event will be independent when A given B has occurred equals A given B has not occurred, okay? This complement is very important here, giving that it equals the probability of A. It's also going to be the case when probability of A times probability of B equals the intersection. Now, this means the probability of B given A has not occurred, and it's going to equal the probability of B intersection A complement, which means the values in B only, okay? Not in B and A, not in intersection, in B only, divided by the probability of A. Lastly, what does this symbol mean here? It's very important because it's the universal set. It's everything added up in the Venn diagram, the things inside and outside the whole Venn diagram. This formula right here, just have a look at it once. It's not very important. We probably use this without really thinking about the actual formula. Yeah, it just doesn't really matter. Anyways, complementary events. So these are events that are mutually exclusive and are going to add up to 1. So they cannot happen at the same time. Now, this is the formula. An example is going to make it make sense now. An example of this would be raining or not raining. They're mutually exclusive because they cannot happen at the same time. It can't rain and not rain at the same time, okay, in a given area, but you know what I mean. If it's not raining, it's 0% raining, okay, if that makes sense. Now, let me think of another example. Okay, so when you're tossing a coin, you can either get tails or heads, right? It's 50% for both, okay? 50% for both. And because it's 50% for both, if you add them up, that's 100%, okay? Let's draw this. That's 100%, that's one whole, okay? So it's going to be 50% plus 50% equals 1. And are they mutually exclusive? Yes, because they cannot happen at the same time. Last slide, okay. I'm going to do some drawing here. Probability distribution. Okay, this is the probability of each outcome in a random process. All probabilities added together will always equal 1. So there's discrete and continuous values. Discrete is when they can be counted or they are unique. Okay, so you can count numbers in 1, 2, 3, 4, or -1, -2, -3, -4, and they're unique when it's, for example, apples or bananas, 1 or 2. So there's no decimal places here. Okay, well, yeah, there's no decimal places, there's no measuring. In continuous, there's measuring. So height, for example, can be in decimals, and it's in centimeters. Okay, it's measured, it's continuous. Discrete uniform distribution is when all outcomes have the same probability of happening. And remember that they're going to all add up to 1. Okay? So, for example, you have x. 1, 2, 3, 4, 5, and 6 are all the possible outcomes. If the probability is discrete and uniform, this means that the probability of any of them happening is going to be 1/6, and this is how you represent it with this p capital X equals x. Okay, so this is the probability that a random variable in x takes value x, either one of these. Okay, just have in mind this is how you represent it, this symbol right here.